Okay, so in this video, I'm going to review what we've been doing on solving essentially nonlinear inequalities. Let me just hide that there. Okay. All right, so um, let's start with, I don't want that. Here it is right here. That should be it. Okay, so I'm good to go. All right, so the first one, and what I recommend doing is pausing the video and trying to solve it as much as you can, and then playing the video to check your answers. All right, so let's take a look at this first one. X plus 2 to the third times x minus 1 greater than or equal to 0. So in all these problems, we have to set the inequality to 0. We have to make sure it's factored, or it has just one fraction. And if we don't have one fraction, then we've got to get a common denominator. Well, we don't have a fraction here. So it's set to 0, it's already factored. And my critical points, again, come from setting each of these factors equal to 0. We would expect at both of these that the graph would cross the x-axis because the multiplicities, the powers belonging to those zeros, are odd, which means on my number line, doing the candidate test, all signs have to alternate. So I'll put these numbers down on my number line, -2 and 1. And because of this part right here, the equal to, these will be closed circles. I need a test point to the left of -2. Surprise, I'll pick -10. Where am I putting the -10? I'm putting it in for x. So -10 plus 2 is a -8, but a negative cubed, a negative to a third power, is a negative. -10 minus 1 is a -11, but it's negative, and a negative times a negative is a positive. So that means on this interval, the function is positive. Now, as a shortcut, these signs have to alternate: positive, negative, positive, because the powers belonging to those zeros is odd, so they have to alternate. Now, to answer the question, where is the number line positive, is where my function is greater than or equal to 0. So this is where the number line is positive, and that's like technically where I'm shading. Now, using interval notation, that means using parentheses and brackets, what's my answer? Well, this is from -infinity to -2 bracket, because I'm including the -2 with the closed circle, and then from 1 to infinity. And once again, I'm including 1 because it's a closed circle. You could have also done it the long way, where you've picked a candidate between -2 and 1, like 0, and substituted that in for x. And 0 plus 2 is, 2. 2 cubed is a positive. And 0 minus 1 is a -1 to the first power is a negative, and a positive times a negative is a negative. And then you could have also over here had picked 10, substituted that in, got a positive times a positive. You'd have gotten 12 cubed times 9, and that too is a positive, obviously. So you can either do it the long way by picking test points always within these ranges, or you could do the shortcut. Number 2, suppose we have here x squared is less than 4. Sometimes the simplest of problems, students think that they can do that as x is less than plus or minus 2 or something. You can't do that because it's a quadratic. So you've got to take the first step by setting it to 0. And that would be achieved by subtracting 4. The second step would be to factor the expression completely, and that's a difference of 2 squares. I see that my critical points are 2 and -2. So my third step, I'm going to build a number line with -2 and 2. Because there's no equal to part, both of these will receive an open circle because they will not be part of the solution. So a test point, no surprise, to the left of -2 is -10. I get a -12 times a -8, and a negative times a negative is a positive. And again, I'm going to use my lovely shortcut that the signs have to alternate positive, negative, positive, because these powers belonging to those roots is negative. Now, where am I greater than 0 is where the number line is positive. And that's happening from -infinity to -2, and then from 2 to infinity. Again, in reflecting about our work, this is a parabola. Its vertex is 0, -4, and its zeros are -2 and 2. And there I have my parabola. That's a basic function that we've gone over and learned how to graph in great detail. Here are the zeros, -2 and 2. The vertex I missed down there, but it's 0, -4. So here I have my positive y's, my negative y's down through here, and then my positive y's. So it does make sense. And one more type of polynomial is, suppose we have x plus 2 squared times x minus 1 is less than 0. So it's already set to 0 and it's already factored. So my critical points are -2 and 1. I'm going to make a number line, -2 and 1. Everything will receive an open circle because there's no equal to part. If I pick a test point, what a surprise, like -10, substitute that in for x. And -10 plus 2 is a -8. But -8 squared is a positive. So that, I mean, like really, you can ignore any even power because it's just always a positive. But you can't ignore this over here because -10 minus 1 is a -11. And that positive times that negative is a negative. So that means the values are negative on that interval. I'll do my shortcut and also do it the long way. So the shortcut, we've got an even multiplicity, that's even, belonging to this root, -2. So the signs have to be the same on the two sides. So if it's negative on the left, it's got to be negative on the right. And then because this 1 came from an odd power, the graph is going to cross the x-axis. Here it's bouncing off the x-axis. It's going to alternate back to a positive, or alternate to a positive sign. So where's my number line less than 0? Or I'm sorry, where's the function less than 0 is where the number line is negative. Got to be careful with my words there. Where the function is negative, that means where it's less than 0, is where the number line is negative because that's where my graph lies below the x-axis. So what are my answers here? -infinity to -2 in union with, or you can just put here -2 to 1. You cannot put -infinity to 1 because at -2, the function is 0, and 0 is not less than 0. So it has to be broken up there. If you wanted to do it the longer way, well, we already picked -10. We can pick 0 in the middle. I know anything squared is a positive, but 0 minus 1 is a negative, so that's going to make that positive times a negative. And if I pick here +10, I clearly get 12 squared times 9, which is a positive. So that's the longer way. And now the rational ones, where we got the x in the denominator. So here is a basic one. What's nice about it, again, it's already set to 0. It's just one fraction. But this time, in getting the critical points, we need to set both the numerator and the denominator equal to 0. So the top critical point is -2, and the bottom critical point is 3. Just want to hide that there. Okay. So now, because there's no equal to on this at all, it's going to be all open circles. And remember, regardless if there was an equal to, any critical point from the denominator, any denominator critical point always gets an open circle because you can't divide by 0. All right, I'll do the same thing. Pick -10. -10 plus 2 is -8, and -10 minus 3 is a -13. And a negative divided by a negative is a positive. Again, the shortcut, because these multiplicities are raised to an odd power, they will all alternate. Positive, negative, that's how we alternate signs, and then positive. So where am I less than 0? Where is this function less than 0? Is where the number line is negative. And that's happening from -2 to 3 with parentheses. Okay, 2 more. Suppose I have x plus 2 over x minus 3 is greater than or equal to 2. So this time it's not set to 0. So I will achieve that by subtracting 2 from both sides. But you've got to make one fraction. So I'm going to have to times top and bottom by x minus 3 to get a common denominator. So the numerator will give me x plus 2 minus 2x plus 6 all over x minus 3. So again, when I took the 2 over, I subtracted, and you've got to get a common denominator. I got to make these the same. So I'll times top and bottom over here by x minus 3. But you got to distribute that minus sign through, and now collect like terms. So x and -2x makes -x, be careful, plus 8 over x minus 3. Again, the critical points, set the numerator and the denominator equal to 0. And the top critical point will be when x equals 8, and the bottom critical point will be when x equals 3. But because we got an equal to part, so something's got to be closed, and something's got to be open because we're dividing by an x. So the denominator's critical point will always be open, while the numerator this time will be closed. So again, this triggers a closed circle, but it's only the numerator's critical point will get the closed, and the denominator will get the open. Again, I got all odd multiplicities here, so every sign's going to alternate. But be careful now, because that x is negative. So if I pick 0 for x, a little easier to work with, I think. I'll get negative, it's just 0 plus 8 is a positive, and 0 minus 3 is a negative. And any positive divided by a negative is a negative. They have to alternate, guys, because they're odd multiplicities. So there's our shortcut. If you don't like the shortcut, again, pick a candidate between 3 and 8, like 5. Substitute this in, and you'll get -5 plus 8 over 5 minus 3. Well, that's 3 over 2, which is a positive. If you're unsure, pick 10. You don't have to do the shortcut. Pick 10, put it in for x. You'll get -10 plus 8 over 10 minus 3, which is -2 over 7, which is a negative. And now time for my answer. Where is the number line positive is where the inequality is greater than or equal to 0. So that's not the answer, though. That's where the shading is. That represents the solution on a number line. But the answer is written using interval notation, parentheses at 3, bracket at 8. And the last one is, now suppose we've got something like this, where it's already factored. And first and foremost, it's set to 0, and it is just one fraction, and it's factored. So again, to get those critical points, we're going to set both the numerator and the denominator equal to 0. So x would be equal to 1 from the numerator, x would be equal to -3 from the numerator, and from my denominator, x would be equal to 2. There's no equal to part, so every critical point will receive an open circle. Make sure I put them in order. One time I made that mistake. All right. So what's a critical point? A test point to the left of -3, -10. Again, think about this. Anything squared is a positive. I only worry about the negatives because an odd number of negatives multiplied is a negative or divided. And an even number of negatives multiplied or divided is a positive. But if you choose to put it in, that's fine. You square it. And maybe some of us need to write this out. Well, that's a positive times a negative and a -12 on the bottom. Those even number of negatives will combine to give me a positive. I'm going to do the shortcut now, and I'll revisit it using the long way. So now, how will my signs go? The question mark is it a positive that's next, or is it a negative? Do the signs alternate, or do they stay the same? Look no further than that power, than where that root came from. That power is odd, so the graph has to cross the x-axis there, which means the y's will alternate in this case from positive to negative. Now at 1, or going to the right side of 1, will it be a positive or a negative? Will it alternate signs, or will it be the same sign? Well, 1 came from this even multiplicity, this power of 2. 2 is even. So it's got to be the same sign on both sides, which means the graph is below the x-axis. There's tangent to the graph of f at 1 from below. And then 2 comes from this. What's the question mark? Is it the same sign? Is it going to be minus, or will it be plus? Look here at this critical point 2, came from the odd power, so it's going to alternate. So where am I greater than 0 is where my number line is positive. And that's happening from -infinity to -3, and then from 2 to infinity. The longer way, if you want to pick a test point, well, between -3 and 1 is 0. So then I'm just going to put in 0 for x. And that's a positive over a negative, negative. What's between 1 and 2? Well, you got to pick 1.5. 1.5 in for x. Clearly a positive, positive, and 1.5 minus 2 is a negative. So positive over a negative is a negative. And if I clearly pick, say, 10, I clearly get a positive, 81 times a positive 13 divided by a positive 8 is a positive. So once again, you don't have to do it the shortcut way. Thinking about whether it's crossing or is bouncing off the x-axis, you can also do it the long way by picking critical points. They are test points between the critical points. My critical points are these. These are my critical points. These are my test points. And that's why we call this the candidate test, because we're picking for values of x. We're picking candidates to test. And those candidates are numbers, that lie within each of these intervals. And interestingly, it will tell us what the sign of y is by putting that value in for x. Because think about it, we've divided up the function where it hits the x-axis or where the graph has a vertical asymptote. We found the critical points, and those critical points happen when a function hits the x-axis or in some instances has a vertical asymptote. So I hope this video helps you and that I did 3 problems here. The first 3 were just your typical polynomials. The only one I had to factor over here was that. And then the last 3 were your rational ones. The biggest thing with the rational ones is you just have sort of maybe an additional step or two that after you set it to 0, you just got to get a common denominator so that you can combine the fractions into 1. All right, I hope this helps.